Here is the last example on logistic growth model. The student population at OOU can be modeled by the logistic growth model below, with initial population taken from early 1960s. P of t is equal to 30,000, 1 plus 5 exponential to the negative of 0.060. Determine the initial population and find the population of the students in OOU in 2014. What will be the population of students in 2050? So we have to find the initial population. So our initial population, it means we have to find the initial population at t is equal to what? 0. So we now have 1 P of t is equal to 30,000 according to the logistic growth model we have been given, all over 1 plus 5 exponential minus 0.06. Our t is what? Time. So we have to determine the initial population. So our initial time will be 0. So we now have 30,000 all over 1 plus 5 exponential to the negative of 0.06 times 0. If this one multiplied by 0, we are going to get 0. Exponential to the 0 is what? 1. So if you multiply 1 by 5, we are going to get 5. 1 plus 5, we are going to get 6. So we have 6. 30,000 divided by 6, we are going to P of t is what? 5,000. So we now have 5,000 students. The initial population of the students. The initial population is 5,000. So number 1 consists of 2 questions and we have to solve it. And find the population of the students in OOU in 2014. So we have to find the population of the students in OOU. Our t is equal to 2014 minus the initial population at early 1960. 2014 minus 1960, we are going to get 54. So our P of t, we are not given. We have to find the population in 2014. So we now have P 2014 is equal to 30,000, 1 plus 5 exponential to the power of 0.6. Then our t is what? 54. So now P 2014 is equal to, if you multiply 0.06 times 54, we are going to get 0.06 minus 0.06 times 54. We are going to get minus 3.24. So exponential, so we are going to have 30,000, 1 plus 5 exponential minus 3.24. So if you take the exponential to the power of minus 3.4, what are we going to get? We are going to have exponential minus 3.24. We are going to have 0.0392. So we now have 30,000 all over 0.0392 times 5. We are going to have 0.1958 plus 1. We are going to have 1.1958. So now 1.196. If we divide 30,000 divided by 1.196, we are going to have 25083.6. So our P of 2014 is 25,084 is our population. So our population in 2014, or our population of the students in 2014, which students, the school of what? OOU, is 25,084. So this is the population in 2014 of OOU students. Now, what will be the population of students in 2050? It means for us to calculate the population of the students in 2015, our 2050 will subtract, we will take 1960 from what? 2050. So 2050 minus 1960. If you subtract 2050 minus 1960, we are going to get 90. So our t is what? 90. So our population in 2050, population of the time in 2050, 30,000 1 plus 5 exponential minus 0.06. Our t is what? Our t is 90. So minus 0.06 times 90, 0.06 times 90. We're going to get 5.4. If you multiply 5.4, negative 5.4. So exponential negative 5.4 is what? Exponential 5.4. We are going to get 0.00451. So if you multiply it by 5, we are going to get 0.02258. So if you add it by 1, we are going to get 1.0225. So our population in 2050, 30,000 all over is 30,000 over 1 plus what? So we have calculated this, we got 1.023. So if we divide 30.03, 29,29325.5132. So approximately it will be 29326. So our population of the OU students in 2050 is 29,325.5. Approximately to what? 29,326. So our what the population of students in OU in 2050 is 29,326. So this is how to calculate the logistic growth of the population of the OU students. So don't forget to like, share and subscribe so that whenever I drop videos on any topic, you'll be notified.